If you look at the periodic table, at the top left column of the periodic table, we have an element called hydrogen with the symbol H and the atomic number to be 1, even the mass number to be 1. This atomic number to be 1 means that there is only one proton present in the nucleus of the atom of hydrogen. And this atom to be neutral, it means that the total number of proton is equal to the total number of electron. That is to say, we only have one electron revolving around the nucleus of the atom of hydrogen. When we have to have what we call electron distribution around the nucleus of an atom, which we can also call electronic configuration or electron configuration, using the KLMN shell, since the lowest energy is K, there is only one electron that is going to be found at the K shell of the hydrogen atom. We know that the maximum electron that is required for K shell is 2. And this means that it is possible that hydrogen can give out this one electron to look like the alkaline metal, or it can accept electron to look like the halogens. Now, when it is accepting electron, it means that it is reacting with highly electropositive metal that gives out electron to it, which we can have something like sodium hydride, potassium hydride, calcium hydride, and all these hydrides are ionic in nature. But when it is bonding with non-metal, it means that it is going to be giving electron to those non-metals, and it's going to form something like hydrogen chloride, it's going to form something like ammonia, it's going to form something like hydrogen sulfide. Here we are going to have the hydrogen acting as a positive ion, giving out electron to the non-metal. That is why we find it difficult to place hydrogen in any group in the periodic table, because it can actually lose electron or gain electron, which will look like metal at group 1 or look like the halogen group at group 7. Despite the fact that the atomic number of hydrogen is 1 and the mass number to be 1. Now, if you look at, we have 3 isotopes of hydrogen. One called protium that has only 1 proton and 1 electron. And we have deuterium that has 1 proton, 1 electron and 1 neutron. And we have the tritium that has 1 proton, 2 neutron and 1 electron. Now, by the mass number for protium, the mass number is 1 because there is no neutron in it. That we have P plus N, where the P is proton and the neutron is N, and there is no neutron. We have only 1 proton to give us the mass number. Now, when we go to the deuterium, we have 1 proton and 1 neutron. Since we know that mass number has to do with the summation of the number of proton or mass of the proton and neutron, here we are having 1 plus 1 to give us 2. That is why the mass number of deuterium is 2, and its name is actually coming from the word 2, deuterium. Now we have the last one, the tritium. This tritium has 1 proton, 2 neutron and 1 electron. Now, since we are working with mass number, which will give us proton number and neutron number, we have 1 plus 2 to give us 3. That is why it is called tritium. Tritium means that the mass number is 3. And for us to get mass number, we have to add the proton and the neutron together. Now, the resistance of this proton is over 99.9%. But to be precise, we have 99.97%, and here we have 0.03%, and here we have no percent. This one is actually radioactive. It is being manufactured. What I mean, the tritium is being manufactured by the chemist through radioactivity. Hydrogen gas was first prepared in 1672 by Robert Boyle. Actually, what he used was reacting iron with tetrodorsophysic acid, where there is evolution of hydrogen. And secondly, was done in 1766 by Henry Cavendish, who used zinc reacting with hydrochloric acid to produce hydrogen. But none of them gave a name to this except our father of chemistry, whom we know as Antoine Lavoisier, who named hydrogen the name gotten from a Greek word which, when translated in English, represents water former, because he believed that when hydrogen reacts with or combine with oxygen, they form water. The reactants that are necessary for us to prepare hydrogen in the laboratory is mostly the highly electropositive elements and water or acid. The reason why we use the highly electropositive element is that we believe that in a displacement reaction of metals and acid, we are going to have hydrogen liberated as hydrogen gas. Or if we are using water, the highly electropositive element will displace hydrogen from either acid or water, although each of them has different way of reacting with the acid or the water. For drying agent, what we normally use for drying agent is tetrodosulfaceous acid, because you know that tetrodosulfaceous acid is a hygroscopic substance that absorbs water from the surrounding. Therefore, if there is water content in the hydrogen gas coming out, that tetrodosulfaceous acid is going to absorb the water and make the hydrogen to come out plain as a dry hydrogen. For method of collection of hydrogen in the laboratory when prepared, we normally use the ideal one, that it is the lightest gas, and secondly, it is not soluble in water. Because it is not soluble in water, we collect it through water, so that there is going to be a downward displacement of water, where it is going to take up the space of water while the water is going down. By zinc granulates is zinc with impure copper. The reason why we use this impure copper is to help quicken this reaction. What happens when we have zinc reacting with hydrochloric acid? We are going to have a displacement reaction where the zinc will take the place of hydrogen in hydrochloric acid, as you can see on the screen with the equation. Sometimes you can be asked question on how can you be able to prepare hydrogen from cold water or tetrodosulfaceous acid. What these people are just trying to ask is, do you actually know the ideas of the reactivity series? I have a code that I always use for my students on the reactivity series, because this reactivity series helps us to know what can actually prepare hydrogen in displacement reaction. I have here K, Na, Ta, Magi, Allow, Zun, Fi, Snell, Lom, Hai, Ku, Hajia, Adia, Oru. This is a way I normally use to remember this. Potassium and sodium can react with cold water, and look at the reactions on the screen. Okay, we have again for the tetrodosulfaceous acid. You know, tetrodosulfaceous acid is one of the strong acids, therefore it might not actually be able to react with most electropositive elements. We have here K, Na, Ka, Magi, Alazun, Fidi, Snell. We can actually use that to react with tetrodosulfaceous acid. We can have a liberation of hydrogen. Yes, Snell, which is the tin and lead, can actually react, but the reaction will not be as easy as when we react with the K, Na, and Ka. I hope you know what I mean by the K, Na, Ka: potassium, sodium, and calcium. Most times when we are being asked to give properties of a substance, we who have many information still lacks information to give out. For instance, if you are being asked to give out physical properties of hydrogen, if you check some textbooks, they will tell you that hydrogen is colorless, odorless, and tasteless gas. But let me tell you, these are three different things that we are supplying as one information. Therefore, if you are being asked to drop 4 or 5 properties of hydrogen, it will be better for you to tell them that by color it is colorless, by taste it is tasteless, and by odor it is what? Odorless. Than writing it is odorless, tasteless, and this and that. And the person is going to mark this information just as one delivered information. The other properties of hydrogen is that it is slightly soluble in water. To be frank with you, that is even the reason, as I said earlier, in the preparation of hydrogen, that is the method of collection of this hydrogen gas. That is why we use the collection through water, because it is not soluble in water. Hydrogen normally has no effect on litmus paper, whether it is moist or dry litmus paper, whether it is the red or the blue litmus paper. And secondly, hydrogen does not even support combustion. But not supporting combustion does not mean that it cannot burn, because in the presence of oxygen, it burns to form water. Third, you need to understand that hydrogen can react with nearly all the elements, mostly the non-metals and the metals. When it reacts with metals, we form what we call metallic hydride, which we know is supposed to be ionic. But when it reacts with non-metals, we have hydride, which are mostly covalent compounds. Fourth, it displaces those electropositive elements that are below it. Remember when I recited my mnemonics, K, Nakam, get allowed, zoom, feed, snare, plumb, high. After the high, which is the hydrogen, the next one we are going to have is cool, Hagia, Orum. That is the copper, mercury, silver, and gold, including platinum, can be replaced by hydrogen in their oxides or compounds, as you can see on the screen. And the next thing you need to understand is that hydrogen is made use in the hydrogenation, where we have hydrogen going across the double or triple bond of something like oil, ethene, alkene, and alkyne. To actually know that the gas that is coming out when hydrogen is prepared, what we normally do is to bring a burning splinter. And when you bring a burning splinter close to the test tube, you are going to hear a pop sound. If actually you know the definition of chemistry, we define chemistry as a branch of science that deals with matter, its composition, structure, properties, uses. That is to say, we have to look into the uses of hydrogen for us to understand that we have completed this work. The most important use of hydrogen is in the production of ammonia in herbal process. And this process is very important because from it we can produce triazonitrate 5, which can be used further as dyes. We can still use it as fertilizer, and some can use it as explosive materials. The second most used of hydrogen is found in the hydrogenation of oil. As I said in one of the reactions, this hydrogenation tries to convert oil to margarine, and you can also see something that looks like that when we are trying to convert alkene, or to alkane. Hydrogen is made use in airship fuel and also in filling hot balloon. Although this filling of hot balloon is becoming obsolete because we are scared that hydrogen is going to burn in the presence of oxygen, and that means that it's going to be explosive. People that are inside the hot balloon might get hot or get burnt when it explodes. That is why we are not using it now. Why we are using it then is because it's the lightest gas on earth, which means that if we are with it, it can actually float on air. The fourth reason, we can use it to manufacture other compounds. Most of the compound is like the methanol, and some country that has coal, that's how we will react this hydrogen with the coal at high temperature. We will convert this coal to become petrol, which we can actually use. But one problem here is that it is too expensive. That is, to produce this petrol will be very, very expensive. That is why most people don't use it. They prefer importing petrol from other countries. Another one is used in Aussie hydrogen flame. This Aussie hydrogen flame is used in melting metals. These are the uses of hydrogen. Okay, I would like you to take your little time to answer this question and write it down and pause this video here. I am very, very happy to have you from the beginning of this video till now, and I will urge you not to forget to subscribe. Click on that bell, make sure you subscribe, and also click the link of the share and do it with your social media platforms, and don't forget to like. You are doing this to help me, as I'm also doing to help you.